Hello students, today again we are going to study our chapter that is motion, and this is the part 6 of the video. And if you haven't seen the previous videos, go through it for each and every topic. Today we are going to talk about uniform circular motion, and it is about the constant tangential speed. First of all, we need to know what is a circular motion. Circular motion is the motion of a body in a circular path. It is called as circular motion. That means whenever a path is moving in a circular path, that means this is called as the circular motion. Now next, the term arises over here is uniform circular motion. What is that? If a body moves in a circular path with uniform speed, then it is called to be a uniform circular motion. For example, a boy who is running in this circular path, and he started from this point and ended up in this point. He started running at 10 km per hour speed, and he maintained the same speed throughout his journey. So it would be called as the uniform circular motion. And uniform circular motion is accelerated motion because in the circular motion a body continuously changes its direction. So what we can say here is whenever an object is moving in a circular motion, okay, there is the change in the direction. Can you see over here? This is one part, and then it is changing its direction from here. Then it is moving a little bit inward. Again, after moving an equal distance, then again it is moving, it's changing its direction. Can you see over here? These arrows represents the change in the direction while a body is moving in a circular motion. And this kind of motion is called as the accelerated circular motion, or you can say accelerated motion, in which there is the change in the direction. So the circumference of the circle of the radius r is given 2 pi r. So we need to calculate how much amount of distance is this. So this is the circle, and when we want to calculate the circumference of a circle, the formula is 2 pi r. R is nothing but the radius. Okay, this part is the radius from the center point to the side. This is called as the radius. So from the above statement, we can frame the equation over here it as V is equals to 2 pi r is the total circumference, or you can say the total area, divided by time. So from this statement we have come across this equation, that is V is equals to 2 pi r divided by t. You can see in this diagram, these are the center points, okay, and when a body is moving like this, then you can see there is the change in the direction. Again it is moving, coming here, there is the change in direction, as well as velocity. We can call it as velocity. Here we will call the term as velocity. Why? Because along with the speed there is a change in the speed. If there is a change in the speed, that means there is a velocity. And what is the velocity? Rate of change of speed with the direction. So you can see over here, so this can be considered to be the velocity, okay, and this is the area. In this way, like we can say, this is the area in which a body travels. In a uniform circular motion, t is the time period to go around exactly once. That means if the body started moving from here, it will go around and it will come back to the one position. So when it is moving the whole circle, how much amount of time it took to go around. Then r is the radius from the center point to the sides, that is called as the radius. And what is the diameter? Diameter, you know, the whole, when the circle is divided into two half, so that is the diameter, and half of diameter is the radius, so radius of the circle. And v is what? V is the speed. Here this we will consider the speed as a scalar quantity, not a vector quantity. So from the above statement, v is equals to circumference upon period, that is 2 pi r divided by t. And when you want to take out the time period, so what you will do, you will take this part here and the v will come here. So what will be the formula for t? 2 pi r divided by v. Here is the same thing again repeated over here. This person, okay, is seeing this one, okay, the aeroplane, and it is showing this one. So if you want to calculate the time period, it will be 2 pi r divided by v. Here you will see a very interesting thing over here. Whenever you take a thread and tie it along a stone or any kind of ball, and when you will rotate it in a circular motion, okay, whenever you will rotate it in a circular motion, and in between if you will release the thread, what will happen? The ball will always move in straight line. Okay, always moves in straight line from where the thread was released. For example, if you are rotating in this way and you release the thread from here, okay, this point, can you see this point? If you release the thread from here, what will happen? The ball will straightly move towards the A. Instead of going to B, it will go in a straight direction. In this diagram also you can see there is a ball or the rock. This person is rotating. When you will release the thread at this point, it will move here in this direction straight to this point. And if the ball is released in this position, then it will move in this direction straight to the circular motion. Whenever it is released, so it will move in straight line to the circular motion. As you all know that the moon revolves around the earth, this is also considered to be the circular motion, and this moon, it travels along the orbits. Okay, this revolves around the earth in a fixed position. So this is an example of uniform circular motions. I hope you understood the concept, and I hope this video helped you to understand it. Thank you, students. We will be meeting in our next video with new chapter. Bye bye.